Hello, today we are going to learn how to create snap packages. So snap software from the canonical group Ubuntu. This is the wiki page, snap_software. So there's a packaging technology that works on many Linux operating systems. There's a snap store available with applications that can be run once you install the snap functionality on your Linux operating system. The packages themselves are called snaps. On your system, you install snapd before actually installing snaps. And for creating snaps, the framework is called snapcraft. The website is snapcraft.io. And in there, you can go to the Snap Store where you can find the applications that can be installed as snaps on your Linux operating system. So there's Visual Studio Code. The publisher is Visual Studio Code. Okay, so the upstream themselves, the Visual Studio Code project, is publishing a package that's called code in the Snapcraft, in the Snap Store. Okay. Whereas Sublime Text, another text editor, is not provided by the upstream Sublime Text project or with the developers, but by Snapcrafters. Which is a group of packagers that have published 77 snap packages. Okay. So that was the application store. The format, the file that you actually download from the store, is just one file with the extension snap. It's compressed and it's a squashfs file system inside of that compressed file. Let's actually install the framework that allows us to install snaps. We'll install one snap and then we'll start to learn how to create snap files ourselves. So this is the web page, and we're taken to the Snapcraft GitHub project, where we'll look at the documentation for building our first Snapcraft, our first snap package. Okay, and on the snapcraft website.io, we'll look at how to install one of these software packages. So first of all, let's select one. Let's actually go with Visual Studio Code. And I'm on Kubuntu 2304. This might or might not have Snap pre-installed. Let's see if it's the case or not. So snap list. Yes, Snap, the framework that allows us to run Snap files, exists on my operating system by default. It's pre-installed, and the actual software that's installed using it is Firefox, the web browser. Firefox has required Core 22, Bear, Snapd, GNOME 42, and GTK common themes. Okay. There's install documentation. If on your Linux operating system Snap is not installed out of the box. So Ubuntu flavors, KD Neon maybe, have snapd, the framework that allows you to run snap packages pre-installed. And then on some of the other operating systems, you need to install the latest version of the framework. So let's look, for instance, at the instructions for the Fedora Linux. So it's available in the official package repositories. You go at dnf install snapd, and then you should have /snap pointing to /var/lib/snapd/snap. So create this symlink. Okay, let's do what it says in here. We install the hello world snap and make sure everything works okay. We already know it works okay because we're in Firefox and Firefox is installed via snap. So it downloads a very ancient snap package, which is core without any version, any numbers. It's installing the, let's look at the differences. So let's take the output and paste it in a difference viewer. So hello world, snap package was downloaded. The version is the newest, which is 6.4. It's from Canonical, and this required the snap with the name core without any numbers after it to be downloaded and installed. All of my snaps come from Canonical with the exception of Firefox, which comes from its upstream, which is Mozilla organization. Okay. And now it says that we should run hello world. So let's go which hello world. And hello world is available in the path environment variable. Because at the end of the environment variable path, the last directory listed there is /snap/bin, which we know is a link to /var/lib/snapd/snap. So let's look at that. Where is /snap? Maybe it's a So it doesn't say that /snap is a symlink. It says that it's a directory. Okay, do we have this directory? So there's no /var/lib/snapd/snap. Just snaps. Okay. So the snap was installed. It's visible in here. /var/lib/snapd/snaps hello world 29 squash fs on snap/hello world /29. Okay, so this is an actual file. Not sure if compressed or not, and this is the mount point. Okay, so we could install the simplest snap, which is hello-world. Our installation of snapd works. We can install snap files. So let's actually see how we can install Visual Studio Code. Let's click the button. In the desktop store. I'm not on Ubuntu, so I don't have probably the desktop store or something. So let's install it from the command line. Choose an application to open Snap. Let's not go there. Requires the password for super user, for my current user. So this requires a third core snap. I had core 22 installed, which is a dependency for Firefox. Then I've installed core, which is a dependency for hello-world. And now I have core 20 for the snap named code, Visual Studio Code. Okay, says that Visual Studio Code is now installed. Let's see how we can start it. We can start it from the Start menu. Okay, so it takes a while. The first launch is slower, plus it probably needs to create configuration files for my user because this is the first time I have installed Visual Studio Code. Let's see subsequent not cold starts. So it was instant, less than 1 second. Okay, let's see if Visual Studio Code is in the path environment variable. It is. So we can just go code and the current directory. Trust, yes. Let's look at bash rc. Okay, there's code highlighting, opening directories works. So it seems that Visual Studio Code works as expected. Okay, so by now we know that we have snap support installed. We've installed 2 snaps. Now let's get at the part where we create our own snaps. Okay, so the starting page is github.com/snapcore/snapcraft. In the readme.md, there's documentation for building your first snap. Okay, so let's go at the overview. Says snapcraft is a tool to create that runs at the command line and creates snap packages. It also allows you to publish to the snap store. There's ways of having more than one version of the same snap available in the store by using channels, tracks, branches. Snaps run in their own thing similar to a chroot, and you have the possibility of debugging, so of opening a console inside of that chroot. We can install snaps locally without actually publishing it to the snap store. We have snap support already installed. We were at this page already. Okay. So let's start with installing the tool named snapcraft. This is the channels table, so there's channels, tracks, and branches. Okay, so we've installed snapcraft. With this line sudo snap install snapcraft classic. I've created a directory. I will create a snap project that's named my-hello. And inside, this isn't just an empty directory. Inside, we'll need to initialize the structure. So we're using a scaffolder for snap. Snapcraft space init. Okay. This creates a snapcraft.yml file. The wrong name. The name I want to be my-hello. So it depends on the newest core, which is 22 for Ubuntu 22.04 LTS. Does not contain any parts, any plugins. It's empty. It has just name, version, description, grade devel, and confinement dev mode. So confinement dev mode means it can do anything a deb file can do. So it's not using the strict confinement. Very similar to the classic confinement. And grade, it's devel not stable. Okay. After we've created the skeleton of the directory of the project, we need to build a snap file. Okay, This said that LXD is required but not installed. Do you wish to install LXD and configure it with the defaults? I pressed UI and enter, and it has installed LXD using snap. So from the snap store it installed the snap package LXD. Okay, and now it says that my user is not in the LXD group. And it's not. Okay, so I'll need to add the current user to the LXD group and then restart the computer. Let me see how to do that. Okay, so I should run sudo usermod -a-g group name. The group name is LXD, this one, and my username is administrator. So I've run the command line cat/etc/etc/group, where it says that administrator is member of the groups samba share, lp admin, users, plug dev, deep, IP, sudo, etc., but not member of LXD. So let's do that. So group name LXD and username, this thing. Let's look at the groups again. And now LXD is a Linux user group, and administrator is a Linux user that's member of this group. I'll need to restart the machine and I'll be back. Okay, so I've restarted the computer, and now if I run groups, it says that my user, which is named administrator, is member of the Linux user group LXD. So let's try building the snap again. Says launching instance. So it needs to create a container where it will build the snap. Using LXD. So it confines the build environment within a virtual machine. So it doesn't say anything about a container, so it says virtual machine. Isolates potentially conflicting libraries and other files from your host system and vice versa. Actually, launching the instance will require that it downloads the virtual machine image, or it creates it using multipass. Once it creates the virtual machine, then subsequent launches will be way faster. Ubuntu VMs on demand for any workstation. Get an instant Ubuntu VM with a single command. Okay, executing parts, and now it's actually inside of that virtual machine running the parts which are describing how to actually build a snap. There's just one part which is called my part, and for each of the parts it runs the steps of pull, build, stage, and prime. And at the very end says create this snap package my hello 01. So it creates the package in the current directory. My hello version 0.1 AMD64 snap. Okay. Which now we can, that's the snapcraft lifecycle. Okay, and we're going to test the snap locally by using the parameter --dev mode because we're using the confinement dev mode. So let's go. Install. Sudo snap install, the name of the package, the snap package which is my something. Auto completion does not work. And then --dev mode. Okay, says my hello installed. And now we have two snaps with hello in the name. There's hello world, and then there's my hello. Okay. There's no executables inside of my hello, so there's nothing in the path environment variable. Okay. And now we're going to, since we have built our first smallest possible snap file, we've installed it, everything works correctly, all of the dependencies have been installed and configured, so snapd, snapcraft, lxd, a build virtual machine for lxd, everything works correctly. Now we're going to follow a YouTube tutorial which is called Snapcraft Live, a beginner's guide to building snaps. Okay, so let's look at the snap command line. There's a man page. The simplest command line there is a version one. Snap space version. So let's go there. So snap, snapped are installed. Says the version of my operating system and the version of my kernel. Okay, let's see if Snapcraft has a manual. Nothing. This is the short help, the usage for the snap command line. So the command line is used for installing, uninstalling, configuring snap packages. Let's see snap. It was list, to list all of the packages. We were at snap version. Daemons, start, stop, restart, logs, interface. app aliases, quotas. Okay, so this is the tool that we usually use for installing, uninstalling, listing the installed packages, getting information about a snap. Let's see the information about Hello World, for instance. So we can see in snap list that Hello World is installed. How do we get information about it? Snap info, and then as parameter the name of the snap. The Hello World of snaps. No license key set. And there's it's the same version 29 in all of the channels. Stable candidate beta edge. Maybe not. Okay, what does snap find do? Queries the store for available packages. Says that inside of the snap stores there's snap packages for IntelliJ IDEA community, which is a Java integrated development environment, and 2 more IntelliJ IDEA versions. There's also additional IDEs, integrated development environments from JetBrains, Rider for C#, Golang for Go. Irfan view. Inkscape digicam. Okay, so that's for searching. Okay, next. Okay, next up we should try to create a snap package out of the GitHub project GoTop from CJ Bassi, Caleb Bassi. This says the repository has been archived 3 years ago, and a maintained fork of this GitHub project exists at XXX ser XXX. So let's go here. We make sure it's still built using Go as its parent. It's still a text user interface application similar to Top, but written in Go. Okay. The next step is to git clone this Git repository. So git clone, and then and it worked, cd go top. Okay, let's look at how things look in here. So the entry point is the file readme.md. which is the readme file that we can see in the GitHub page. In order to install it, we can either install from operating system packages or from other packagers. And from source code requires go at least version 1.16, and then it offers this command line. We don't have go installed. Okay. The next step is to actually build it, but not inside my operating system, but inside the virtual machine that's managed by LXD, that's managed by multipass, that's needed by snapcraft. For that, we're going to need a snapcraft file to be added to this Git project, so to GoTop. Listing. Okay, it says that we should not pollute the existing Git branches and create a Git branch of our own. So the branches are named master, that's the master local branch, and the remote origin master branch point to the same place. A commit from 6 months ago. Okay, so it's basically in maintenance mode, this GitHub project. A small number of commits in the current year. Just 1, 2, 3, 4, 5, 6, 7. So let's create a new branch in here. Add snapcraft support. And check it out. Okay, so now the current branch is add minus snapcraft minus support. Okay, and now we can run the scaffolding. We can run it from the terminal in do we have a terminal here? Yes, we do. So what was the incantation? Snapcraft init. Okay, so it creates a subdirectory snap in here, which is not yet tracked. And inside there's a YAML file, which is named snapcraft.oyaml. The same content as we saw before, nothing's particularized in here. Exact same text was used when we ran snapcraft init previously. Okay, now we'll need to edit this file. First of all, let's look at the name. So we want to have values that are similar to whatever is in the website on the inside of the GitHub Git project. So the name of the project should be GoTop, but then we need to make sure there's no GoTop already used. So we go snap find GoTop, and it says that there's at least 2 GoTops. There's one which we do not know if it's related to this GitHub repository, but one which certainly is related to this repository because it's a CJ bc, which is this thing, and then GoTop. So I guess we should name the thing my GoTop. Okay, we don't need this comment. First, before actually committing to a name for your snapcraft and maybe to your main executable and maybe to your project, you should go snapcraft register to make sure that the name that you want to use is not already used in the snap store. So we go snapcraft register my minus GoTop and it will return and it will say that my GoTop is available. But I do not want to publish to the snap store. That's why I'm not checking that the project name is, the snap name is available. Okay, the newest base is okay. So I want Ubuntu 22.04, that's great. Version, we'll keep it as the default one, which is 0.1, says just for humans, the typical version is 1.3.2 or 1.2 plus git. So this could be any string, whereas the real version of the snap, I'm not sure where it is. Maybe it's, I don't know. So the version could be anything in the sense that I can see here digital minus audio. And custom and date and can start with a 0. Okay, so we leave it at 0.1. Summary. GoTop is similar to top. And return in Go. I do not know the summary, how long should it be, but probably shorter than a git commit message title. Okay, and then the description can be anything as long as possible. Okay, let's configure Visual Studio Code to wrap. Are those settings, references, settings, wrap on. Okay, so now the line 6 is shown on 2 lines. I do not need to scroll left, right. Okay, so grade devel and confinement dev mode is the way to start. There's going to be many iterations over this file until you upload the snap to the snap store and switch from the grade devel to grade stable and the confinement from dev mode to strict. Okay, next up, let's save this thing. So we're going to commit to Git from time to time in order to be able to back up if needed. Okay, it complains that it doesn't know my username and password. So let's actually run these command lines. So git config global user.email, git config global user.email. Okay, and the same thing for my user, my name. User.name. So user.email and user.name. Hopefully it's okay. And let's look at the history. So it's committed by me. As snapcraft support a new branch, and then we've added the file that's generated by snapcraft init, plus some small modifications. So package name and summary and description. Not Golang, but Golang. Let's fix that thing. Okay, let's amend the last commit. Go top is similar to top and written in Golang. Terminal-based graphical activity monitor inspired by gtop and vtop. Okay, looks better. And now we still have just one commit, but with the correct name for the programming language. Okay, the next step is to edit the parts. The parts are going to be the name of the executable, name of the Git project. And we want to say that it should use the current Git clone. And let's look at the available plugins. There's auto completion. So one of the possibilities is Go for the current base core 22. And this is a Go project. We know that because it says in here language is Go. And we can also see Go mod and Go some required Go Git repositories. And their checksums and versions. Okay, so plugin should be Go. Let's see if this thing builds. So snap craft mine without any parameters. Or it'll debug parameter. So launching instance. It needs to download an overlay or something such that inside of the virtual machine the Go language and its frameworks are available. Now it's at parts. Go not found. And part my GoTop does not depend on a part named GoDeps that would satisfy the dependency. Launching shell on build environment. So that's actually interesting. How do we exit? So fail to execute pack in instance. Okay, we have debug logs. Let's look at those. So timestamp and then text. Let's run from here. Let's maximize it. Okay, so because we use the snapcraft executable, it took the snapcraft file .yml and tried to build a snap file. Because we gave it --debug command line parameter, once an error occurred and the snap file could not be created, we are given access to the virtual machine. So right now we're inside of the virtual machine such that we can explore the environment and see what's available in here, what's not. If we're in the current directory, we can evaluate the environment variables, etc. I'm not sure where I'm here. So assets, build, CMD, color schemes. In this directory, it's actually the git clone. Okay. Says go not found. There's snap installed inside of this virtual machine that's used by Snapcraft. Inside we have Core 20, Core 22 and Snapcraft and Snapd. So Snapcraft requires Core 20 and Snapd requires Core 22, right? We've seen this previously. It's a virtual machine that uses deb packages. I am the user root. Can I install MC in here? Yes. So we're in tilde/project with the user root. A top level /snap directory. Okay, the same mount. lxcfs. lxc file system fuse. Okay. VDA 1, 2, and 3 /root/project. So the directory of the project of the git clone is now /root/project. We can see it in here. Very, very interesting. Control D to exit. Okay, and back to our snapcraft YML file and see what's missing, why we cannot, why although we say plugin Go, we still do not have the Go dev packages or snaps installed in the virtual machine. Okay, so I have searched for the exact error that I get, which is environment validation failed, Go not found, or part my Go top does not depend on a part named Go depths. That would satisfy the dependency. And I got to the forum page for the Go plugin. So this is probably this course. It's the new way of doing wiki pages based on a flow similar to a living wiki page with comments. Okay, so it says that there's a Go plugin, but the plugin functions specifically differently depending on which base you use. So I'm using the newest Core 22, which has the following specifics. The plugin should be named Go. The Go project should use modules, not Go path. The build environment does not contain Go any longer. It used to contain Go, and it used to contain Go because a Go snap was installed, not Go deb packages. So what we want to do is to add under my Go top a part where it says that it depends on the following snaps to be installed. Which is -go. -go, we can go just, we could also have put Go in here because it's just one additional snap that we need to install for build time dependencies. Let's make sure it's formatted, the file is formatted correctly by selecting the file, and we can see that it uses spaces, so 4 spaces in here, 6 spaces in here, should be okay. Let's run it from the command line and without a debug parameter. It starts the virtual machine, and then inside the virtual machine, it will do pull. It doesn't say that it installs the Go snap, but it does. And everything's done, apparently. A snap package with the correct name, correct version was created in my current directory. That's interesting because that means that inside of the virtual machine we have the git dev package installed. And we do. In order to download the GitHub Git repositories that are dependencies and listed inside of go.mod. In here. The burnt sushi, etc. Okay, let's actually see if the package is okay. Okay, so we'll inspect the content of the snap file first, and then we're going to install the snap file. So we're going to inspect the snap file by uncompressing it. It's a GPG signed compressed squashfs. So for that, we can copy the snap file to its own directory. And then we can go on squashfs on it. So a directory was created named squashfs-root, where we have the executable that we would expect, which is 10 megabytes in size because it's a Go application that's compiled statically, just one executable which does not depend on any shared libraries, any SO files. Let's inspect it in here. There's meta files, this snap YML, which this part I have written, this part I have written, this part I have written, this was created by snapcraft, this by me, these two by me, and this one by snapcraft. Okay, it sets the path environment variable and LD library path. Okay. The GUI directory is empty, and in the bin directory that's just this file, which is an ELF AMD64 file. So ELF 64-bit executable. Dynamically linked. Let's look at its dependencies. It only depends on the libc that's available in the base22 snap. So the libc for AMD64 from Ubuntu 22.04. And nothing else. So it's statically linked, but it depends on glibc, GNU libc. It doesn't talk to the, it doesn't act as a libc, it doesn't talk straight to the kernel using libc style communication with the kernel. Okay, so it seems okay. Let's actually install it. Sudo snap install and then my go top. Cannot find signatures with metadata for snap my go to 0.1 AMD64.snap. Okay, so because we are not using our digital signature to sign the snap file, we're going to leave dangerously and use the command line parameter dev mode. Okay. Let's see if my GoTop is available. Nope. Nope. And nope. So the executable is actually called GoTop, not my GoTop, and is not exposed to the outside world from my snap. So we'll need to do that. So we need a new part of the YAML file. So there were parts. There's apps. There's interfaces. So we're in the apps part or stanza. This and the name of the executable should be the same as my YAML. So my GoTop. Command. That's bean and GoTop. Maybe we should add a step where we rename the executable from GoTop to my GoTop. We'll see if that's needed. We should have done a git commit first with the part that actually works. So this part actually works. This we do not know if it works yet. So where and what? Package builds. Package builds. Not correctly, but it built for the first time. Like this. So let's uninstall it. Okay, and let's build it again. Let's reinstall it. And now my GoTop exists on the path and exists in /snap/bin, which is the last directory in the path environment variable. And it actually is a symlink, so from /snap/bin to /usr/bin/snap, which this then decides what actual snap needs to be used, which is mounted where, what environment variables need to be set, what for LD library path, for path, etc. Where are the SO files for this file, etc. Okay, switch my go top, correct. And my go top now should work okay. What does it work? What does work? What does not work? So no temperatures. Disk usage is strange, to say the least. It doesn't show the disk usage from the host machine, but from a snap container. Shows the processes from my host machine. Sees all of the CPUs of my host machine. No temperatures. Correct memory and swap sizes. Network usage seems to also work. Okay, so we've just ran the application. My go top. Everything's okay. It's a text user interface application. It resizes if you resize your terminal, has colors, has bold, has pretty graphs, and works out of the box. Why does it work out of the box? Because when we installed it, we specified ---- dev mode, which is the weakest type of confinement, which is no confinement at all. Let's now look at a snap that uses multiple channels, which is, for instance, snapcraft.io/Firefox. We can see that it has channels for latest and for ESR. So ESR in Firefox speak is extended support release. And this is meant for enterprises that want to have less updates, less Firefox updates per year, or less major versions of Firefox installed on their organization's machines during 12 months. So this is always behind stable or latest in Firefox ESR. So ESR is version 115, whereas stable is 117, and beta and edge are even newer than that. Okay, and the requirement in order to publish to the stable and candidate channel is that your snap file must not use dev mode containment. It must use either strict or classic. If you go classic, then you have access to the entirety of the host machines, very similar to dev mode, so practically no confinement. But then it will be really, really hard for you to have your application admitted into the Snap Store, because the reviewers will ask, why are you using classic confinement? Are you a text editor? Are you an application that's very legitimate and is pointless without access to the entirety of the host system? So the vast majority of applications are actually using strict containment, and classic containment is only for hand-picked a few snaps, and mostly from the Ubuntu canonical snap people. Okay. So what we want to do is we want to change our confinement from dev mode to strict. Let's do a commit first. Expose slash snap slash bin slash mygotop. Commit. Okay, so this dev mode we want to convert it to strict. Okay, so we have changed the confinement from dev mode to strict. Let's build. Okay, so what strict means is that the application will be very confined. It will be able to use CPU, some memory, and that's about it. It will not be able to use the networking. Will not be able to download from an HTTPS website. It will not be able to use accelerated GPU, OpenGL, Vulkan. It will not be able to read from my USB webcam. Will not be able to play sound, etc., etc. So all of those things are specified. Let's go where we were. So creating a snapcraft overview. So this thing, add interfaces to your snap. Interfaces are a pair of plug and slots. A plug in one snap may connect to a slot in another. What we're really after is that we want a slot that's provided by the Core 22 base snap, which allows us access to, for instance, the list of network interface cards, the speed of upload and download over the internet, the list of processes, the list of CPU threads, the load on each CPU thread, etc., etc., to be made available to the strict confinement that makes sure that mygotop cannot easily communicate with my host machine. So we've built mygotop. Now, since it's no longer dev mode, we can remove this parameter and try to install it. And it errors out in the same way, says cannot find signatures with metadata for snap. So the command line parameter here is dangerous. Okay, so dangerous goes over the error cannot find signatures with metadata for snap. The next thing that we want to do is to actually run the executable and see that Now we get the correct count of CPU cores, 15. We get probably correct graphs here, correct graphs for memory, but we now lack the disk mount, disk usage, which used to work previously. Temperatures did not used to work previously. Probably I do not have the hardware sensors, the package installed on my host machine, so they're not available on the host machine, not available inside of the snap confinement for my GoTop. Okay, so in this page, it's the entry page for setting up interfaces, plugs, and slots for your snap. And we can see that plugs is this part for this command, and then another set of plugs for these other commands. So this is part of the ops chapter inside of YAML. And then at the very end, we have the supported interfaces document. So let's go there. So we're sharing resources from one snap to another snap. In order to be able to use a snap, you need to have inside of your snapcraft.yaml define a list of logs and slots. Okay, and the full list goes like this: account control, account service, ACRN hypervisor, Android, Allegro video, video core unit, audio ALSA, audio playback, audio recording, Avahi, that's MDNS, Bluetooth, at least 2 things, camera, USB webcam, Samba, CPU, cups for printing, another printing thing, dbus, okay, so that's a lot of interfaces, plugs, and slots. One of these if we're going to add to our snapcraft.yml file, then maybe GoTop will be able to display the list of mounts. But we do not know exactly which one is which from here. So we could search for mount. Not this one, because this is about Samba. Maybe this one. Maybe this one. Or about disk. So there's 3 possibilities, or maybe about, I don't know, SSD, NVMe. Nope. But store. Storage. There's one for the home directory. Optical drives. So we do not know exactly which. We could, for instance, add all of these, like all, like this. How do we do that? Control R. We want a space and then anything, and replace that with nothingness and without interface. You know, you add all of this to snapcraft.yml. You see if it works or not. Maybe these are not enough, but if it works, then you can do divided in pair, like delete half of the interfaces. So there's 175 now, 174. So you delete 80 of these ones which do not seem to have anything to do with mounts. So X11, Wayland, unities, you delete 80 of these, and then you're down to 94. If it still works the next time, then you remove the next 50% that don't seem to have anything to do with mount points. If it still works, you do git commits at each of your tries, and once the list of mount points disappears, so the first time it disappears, then you know that your previous git commit has made it disappear. You revert those and comment out half of the other interfaces until you get to the exact list of interfaces that are minimorum required in order to have the list of mounts working correctly. Okay, so let's try and see if we can do such a thing. So Q to exit. This is the snapcraft.yml file. Apps, my go top, we have command, and then here goes plugs. Let's see if the indentation is correct. So the indentation is correct. So we actually need to add this to the start of each entry in this file. How do we do that? Yeah, like this. Okay, let's make sure that the spaces are put correctly, and they are. Let's save, do a git commit. So we're strict, not dev mode, but we've allowed all of the possible interfaces, slots, plugs that existed in the list of available ones. Okay, let's see if this is enough. Maybe it's not enough, not even the entire list. Let's see if this thing builds. and it has built. Now we need to install. Dangerous. Let's see what it says. Has bad plugs and slots. Personal files. Cannot add personal files. Needs valid read or write attribute. System files. Cannot add system files plug. Needs valid read or write attributes. Dbus. Cannot find attribute dbus. Content. Content plug must contain target path. Netlinks driver. Okay. So hopefully it's just a warning, not an error. And now disk usage works identically to the way it worked previously when we had the strict confinement. Okay. And if you want to remove half of the plugs, we would go like this. So we need to press Ctrl X 100 times. No accounts. I don't know what this thing is. This is for Android. Allegro. Avahi. That's for networking. Bluesy. That's for Bluetooth. No Broadcom. No camera. No Samba. No printing. No hard disk encryption. No Docker containers. No capture cards. No firewall. No firmware update. No, what is this? GPIO. Okay, what else? Juju, no Juju. This is probably the audio server jack. No on-screen keyboard. No mir. No multimedia GUI control. No OpenGL, it's a command line application. No phone networks. No dial-up. No Qualcomm. No screencast. No SSH. No Steam. No time server. No crypto TPM. No download manager. No Unity. No Wayland. No X11. Okay, let's see if this thing builds. If it does, we're going to git commit. Okay, let's install. Let's run it. And we still have everything that worked when we had the confinement dev mode. So this is an advancement in the right direction. Okay. Okay. So this would be divided in para, add all of the possible plugs, and then by trying and trying and trying again, comment out 50% and then 50% of the remaining, etc. The other way to do it is to use this tool, which is mentioned here, snapcraft.io/docs/snapcraft-interfaces, which is called Snappy Debug, which is also a snap. So let's try to use this tool and see what it says. For that, we're going to remove the list of all of the plugs. Control S. Let's look at the Git GUI. Where am I? So we've just deleted plugs and all of its children, nothing else. We need to build, install, and then when we run it, we need to use this tool. Okay. Sudo snap install snappy debug. And install my GoTop. We're actually upgrading my GoTop. And then we run GoTop to make sure that the panel with mounts is empty. So this usage, this thing is empty, which is what we've expected. And now it says that we will need two terminals. In one terminal, we run snappy debug. In another, terminal, we should launch the snapped application. Let's do that. Operate the snapped application until failure occurs. There's a ton of failures. Let's close the application. And it says CPU command line is protected by AppArmor. We can we can choose one, either from the source command from the source code of the project GoTop in the Go programming language source code. We stop accessing /proc/pid, so /proc/8/ command line, or we allow the snap access to this thing via interfaces and plugs. Okay, what other type of error we have, again up armor, and this time it's /proc/mounts, then /proc/mount info, and also there's /proc/vm stat, and probably this one /c/block. Okay. In one case says add browser support system observe to procs to plugs to get over /proc/vmstat, whereas for mounts it says mount control, mount observe, network control, network steam, or steam support one off. Okay, so let's add some of these and then try again. So we have suggestions to add one off. So this thing, add one of these, add one of these, and mount control, mount observe steam support, mount control, mount observe network steam, browser support system observe, and that's the last of them. Okay. Back to where was the syntax. So plugs. Let's try with mount observe, and system observe. So at letter M, mount observe this thing. And system observe. This thing. And nothing else. Because mount observe would work here, here, and system observe would work here. Control S. Let's re-B. Where are you in this tab? Snapcraft. Okay, and here says iterating without rebuilding. It can be time consuming, so the developer loop where you edit a file, then you run snapcraft, and then you run sudo snap install dangerous, and then you run your application again. It can be quite time consuming. Like in my case, it's 2 seconds or something. And there's an alternative to iterate over a build. Which does what? Which says snapcraft, and then you tell it a step to go to. So it opens a shell just before, -shell, just before the face prime. or just before build. And you can also start a shell after a step. Okay, so we've built, installed. Now we need to run it after we start Snappy Debug. There's no disk usage. Let's look at the output. Where does the output start? Control C. In here, so says add mount control, which is said previously, mount observe. We have mount observe, right? And system observe, the same things. It says the same things again. Mount observe and system observe, they're there. Okay, so this is how you would use Snappy Debug and then its suggestions, where it says add one off. So add all of them and then you comment out or something until you get to a state where Snappy Debug no longer has suggestions of type add one off. And then Snappy Debug only has suggestions of type up armor. Okay, so we have added to our snap named my-go-top. The interfaces mount-observe and system-observe. And we can see that these are the plugs that are needed by my snap, and these need to connect into a slot, and they're not connected currently. It also says that snap interfaces is deprecated and I should use snap connections. Let's see what snap connections does. So snap interfaces, the name of the snap and then the name of a slot or plug. Snap interfaces, the name of the snap, lists all of the slots and plugs. Okay, and what's snap connections? Snap connections snap. You can not provide the name of the snap, so it will list the connected plugs, slots, interfaces for all of the snaps that are currently installed. Okay, so let's why aren't these slots connected, and why were they these plugs, and why were these plugs connected previously? So let's look at the history for a second. In the previous git commit, we had 100 plugs specified in here, and the list of mounts worked correctly. But then when I removed all of the plugs and kept just two system observe and mount observe, then the list of mounts did not work. Let's do a commit. Such that we can go back to this git commit. Let's go back in history. We'll need to create a branch in here not to lose git commits. And then we're going to move the current git branch to this git commit with 100 plugs. So reset hard. Okay, let's look at the plugs. Contains everything that's needed in here. And we know that if we compile now the application, snapcraft, and we install the snap again and then we run it, the list of mounts will be populated correctly. Okay, so that's my minus. So this usage, this group box works if I put 100 plugs. If I put just two, it does not work. Why is that? So let's go snap connections, my go top. Whereas previously the plugs that we used, which are the mount control, mount observe, was not connected to any interface slot. This thing, mount observe. And the system observe, not connected to any slot, but then many other plugs out of the 100 are actually connected to slots just by me installing the application. I just installed the application. I didn't specify anything that should happen between the plug and slot via the interface. I just specify that my application would like to use the following plugs. Yet some of them have been connected. So audio playback has been connected to audio playback, browser support, core support, desktop, desktop legacy, G settings, home, network, network bind, network status, optical drive, screen inhibit, uPower, observe. Okay, so these plugs are connected to slots, the rest are not. Why is that? Let's look at the difference between the plug network status and network observe. So network status. Network status says this column is set to yes. And this column is called autoconnect. So whenever your snap requires the plug audio playback, that will be automatically connected, auto-connected to the correct slot. So you request audio playback, you're automatically given audio playback. You request desktop, you're automatically provided the desktop slot. Require desktop legacy, you're automatically provided the slot desktop legacy. So some of the plugs will be auto-connected to slots. Not the two that we have kept. So the system observe, that's not auto-connected, and not the other one, which is this. So the other one is mount observe. Mount observe is also not auto-connected. But if we keep just these two, so the workaround is to see if one of the auto-connected plugs can satisfy your application, which in my case it does. If I guess that if I'm just going to keep these plugs required by my snap, then the group box of mounts will be populated correctly. But if I do not want to use this, I want to actually use the other two that are not auto-connected, mount observe and system observe, then once my application is published to the App Store, I can request that the two plugs are auto-connected for just this application. So just for my GoTop, the plugs system-observe and mount-observe are auto-connected. But since my application is not yet published to the App Store, then the decision to allow this application to connect automatically to their slot is not made. So I, as a developer, when I install the application, after I install the application, I need to specify that this snap should be connected to the correct slot. So let's do that. Let's go back to just two plugs. Control S, no need. Let's rebuild snapcraft. So it created the snap package, the snap file. Let's install. Let's look at the list of interfaces. So this says that my snap minus GoTop has two plugs, so it needs two slots. mount observe and system observe, neither are auto-connected, so I need to connect them manually. And the command line is snap connect for that. So snap connect and then snap and plug. If more than one potential slot exists, the command fails. If I do not specify to which slot I want to connect, then it connects to the core snap. So interface connections are between one snap's plug and another snap's slot. If I do not specify which snap and which slot, then the core 22 snap is going to be used, and the slot will be named the same as my plug. And we have auto completion for the command line. Snap connect. The name of my snap is my GoTop. I have two. So autocomplete, I just wrote M, press the M key and then tab key. Okay. This requires elevation. There's just one snap that's providing the slot named mount observe. Otherwise, it would error out. So the connection is now successful. Says that I need two plugs and one is already connected to the slot. Okay, let's do the exact same thing to connect the other plug in my snap. So the other one is system. And now both of my plugs are connected, and we see that this minus changed to colon system observe in the slot column, and in the plug column my GoTop colon system observe became my GoTop. And then we're advised to stop using snap interfaces and use snap connections instead. And we have auto-completion for snap connections command line also. Okay, so this plug connects to this slot in the core snap. And they're connected manually, not automatically. Okay, now would be the time to run the application my GoTop. And now the disk usage mount group box is populated correctly. Okay, so you have two alternatives. Either you require inside of your snapcraft YAML file just the minimum minimorum plugs, and then you publish your application, your snap to the snap store and request that your snap is allowed to have these two plugs auto-connected, such that your end users just install the application my-GoTop from the App Store, and the two plugs are auto-connected automatically. The users don't need to do anything, and they will also install the application not from the command line, but in a graphical user interface mode using a graphical user interface GUI Snap App Store. Okay. Or you might use specifying here the plug that's auto-connected and that provides at least this functionality. And again, the list was of these slots that are auto-connected: audio, playback, browser support, core support, desktop legacy, G settings, home, network by, network status, optical, drive system, screen inhibit control, you power observe. So you specify in snapcraft YAML that you need these plugs, and then rebuild and see that the application works, then comment out some of these, rebuild, see if the application works, so narrow it down and see exactly which of these slots are required for the disk mount group box to work correctly. And then once you upload your snap to the snap store, maybe the security team will say, why are you requesting, I know, desktop legacy instead of requesting system-observe? And then you're going to say, well, desktop legacy is auto-connected, whereas system-observe is not auto-connected. And then the security team will say something, no, switch from desktop legacy, because your application is not a desktop legacy application. It's a new one, you control the source code, to system-observe, and we'll mark your snap in the snap store such that the plug system-observe is automatically connected. So the tools that we use in order to install snaps is the snap command line executable. So snap interfaces, snap connections, snap install, snap remove, etc. And there's also the snapd daemon. So there's snap in here. And snapd, so the host machine runs systemd, which is PID1, which is the init process, and then that spawns snapd with 21 snapd sub-processes. And then this is the desktop manager with an xorg. And this is my X11 session with Firefox running. So my tabs in here as processes. There's also Kate, this process, and Crusader, this process. Okay, so the snap command line application talks to snapd. Let's look at the source code of snap and snapd. So which snap? It's in /usr/bin/snap because this is installed from deb packages. Snapd is not on the path. /usr/lib/snapd/snapd is the executable. And the deb packages are snapd, libsnapd qt, and libsnapd glib. Okay, let's look at the package snapd. For 2304, that's Mantic 23.10. So this is the operating system is Ubuntu 23.10. Let's look at the list of files provided for AMD64. So it uses AppArmor, AppArmor again. There's snapctl executable, snap executable, we've used snap already, and there's snapfuse. In u/usr/lib/snap, there's the various executables such as snapd, snap failure, snap repair, snap confine. Two desktop files. dbus. Man pages for snap confine, snap discard, snap env generator. Auto-completion for the snap command line, for the Z shell, for the fish shell, for bash shell. We saw that the snap command line auto-completes. Snap. Okay, so there's auto-completion there. Let's now look at the source code of the Git repository for snap and snapd, so for the Ubuntu package. The source package for snapd, this guy, has the homepage github.com/snapcore/snapd. And there's two files, the tar.xz with the source code and the dsc file. And that's the place where the Debian source is maintained. There's not an additional Git repository inside the Debian infrastructure. So it's straight the github.com/snapcore/snapd. Contains a Debian subdirectory, right? Okay, so let's git clone this repository and look a bit at the source code. We close this thing. So, okay. Okay, lf2 git clone Ctrl+Shift+V. Start Visual Studio Code in here. This is the Debian directory. Control the entry point file. Okay. So let's look at the source code of interfaces, which supported interfaces like this. Let's look at the source code for system observe. So this thing says read process and system information, monitoring system not auto-connected. The system observe interface allows system status information to be queried, giving privileged read access to all processes on the system. This is a snap interface. Okay, so let's search for this thing. Ctrl+Shift+F. So this is the Debian changelog. Let's ignore the changelog for a while. What is this? Hardware observe go. So the Git source code is written in the Go programming language. We can see programming language is Go 93% of the source code for github.com/snapcore/snapd. There's canonical people in here. Okay. The Go programming language is good for this Git repository because it creates by default executables that do not depend on SO files. Let's see if that's the case with snapd. So this thing. Yes, it's linked statically, so it doesn't depend on any SO file, which makes the executable easier to install. There's less deb packages to install. Just one in this case, just snapd, one package, one deb package. There's no other lib deb packages that are required. And then it's also more fail-safe when you go up to, upgrade and install many dev packages to update your system. There's less chances of breakage, less chances that the snapd executable cannot work because it cannot find the needed SO files. So the fact that it's statically linked is a plus in the case of snapd. You want to have the snapd as reliable as possible because important parts of your operating system can be provided by snapd, such as graphical user interface applications, the printing stack. In the case of Ubuntu Core, most of the operating system is provided as snap packages. So we want this to be as resilient as possible. The other thing is that because it's using technologies in the container confinement, low-level Linux space, there's plenty of source code written in Go in that area. So Docker is written in Go. The libraries used by Docker, I know, OCI, container libraries are usually written in Go. The alternatives to Docker are probably written in Go. So there's a ton of developers, existing source code that are in the same development space as Snap. Okay, back to where we were. So it says hardwareobserve.go, and this is just comments. So it might be the documentation strings. Hardware observe connected plug up armor. Hardware observe connected plug up armor interface allows getting hardware information from the system. So this is part of the documentation of manual pages of the output of the --help command. System observe mock plug snap. So this is for tests. There's a system observe.go file. Indented with tabs, not with spaces. GPL v3. Other first-party libraries provided by Canonical as GitHub Git repositories. So that's snapcore snap, whereas this is snapcore snapd. Okay, so I guess all of these are written in Go. Interfaces up armor. Allows observing all processes and drivers. Not auto-connected. Documentation. Up armor is the technology that's used in order to confine access to /procs to /sys to whatever it other things that are required in order to access the system minus underscore observe information. And also dbus access. So this is the packaging for Amazon Web Services. Probably for the Amazon 2 Linux operating system, and this is spec, probably a spec file for RPM. Another spec file for CentOS 7, for CentOS 8, CentOS 9, Debian changelog again, Fedora RPM spec file, Fedora packaging for various versions of Ubuntu, tests, so the rest are tests. So I'm not sure where the source code of the interface actually is. But what really happens is that inside of the confinement, if you use strict confinement for your snap, you don't have access to any of these. So /proc /cgroup /proc /log /proc /modules, etc. /vmstat /zoneinfo, and then /proc, and then the process ID whatever mount or what was there for sysfs cgroups CPU, and the limitation is created using the technology named, where is it, AppArmor, and these allow or deny access to the full path /proc /11 /cmd line is done via regular expressions. So this thing, /proc /anything, which in this case is the process ID, and then /command line, read-only access. Okay. So we've finished creating a snap for a Go application, application written in the Go programming language. How about we create a snap package from a binary? So from an application that we have the Linux AMD64 binary executable, but we do not have access to the source code of. So there's this application which is called Geekbench at version 6. Let's download it for Linux. Says 64-bit. Let's put it in the directory. So in here we'll try to create a snap package out of it, and we'll name the directory my Geekbench. Which is going to be the root directory. I'm going to create a Git repository in here. Okay, so here we have the tarball with binaries, not with source code. So first of all, let's extract it. So it's gz. So that's minus xzvf. We'll delete, or let's keep the tarball. Or let's rename the tarball. How do we do that? Let's create a shell script file. Shebang. This thing. And then rename. The directory such that we remove the version. So it's just Geekbench Linux. And then it also removes the tarball. Let's make a copy of the tarball first. And clean up first. So I'm deleting all of the directories. Let's do that. Copy the archive from the parent directory. I'm extracting the archive. I'm moving the directory. Tar has a command line parameter. Let's maybe use that. Something like uppercase D. Uppercase C. I'm not sure which one, but there was something with the destination directory. Minus C and exclude Yeah, too complicated. Let's ignore that. Okay, so we're deleting all of the directories, of the subdirectories. We're copying from the parent directory the archive, extracting it, renaming the directory, and then removing the tarball. Let's see if that works. Okay, so bash pick. Okay, so that's what we expected, just one directory named geekbench without any version minus Linux, and in there it extracts the files. We can eventually run make again. So we're extra clean. In the parent, we just have the source tarball file. Okay, so this is how it looks like. There's the following executables. We sort by size descending. And there's one ELF file that's optimized for Intel AVX. And then the other one is for plain AMD 64. Again, Linux executable ELF. So ELF, Linux executable, and probably not many SO files as dependencies. So it does depend on libc, and it says in here that supported operating systems are Ubuntu 18.04 or later. So we're on Ubuntu 23.10, so that should satisfy this requirement. Okay. So this is going to be a Git repository. This is going to be the initial commit. Okay, initial commit. Next up, we're going to run snapcraft init. Snapcraft also has bash autocompletion. So this runs the scaffolding, creates a subdirectory named snap, creates a file snapcraft.yml. Let's open it with Visual Studio Code. Let's have side by side the previous snapcraft.yml file and the new one. So the name should be my Geekbench. The same base. Okay, again, go snapcraft register to make sure that this snap name is 3. I'm using the best base, which is Core 22. Version 0.1 is okay. Let's prepare a summary and a description. So Geekbench. All of these things as description. Okay. Summary. could go like this. 79 characters long maximum. We start with grade devel confinement dev mode. And the plugin that we want to use is the following. So says snapcraft plugins. Let's go to this directory. Not in here, but in here. Snapcraft plugins. We do not want to compile anything, not use GNU Make, not use GNU Auto Tools, not G++, C, C++, Go, Python, Node.js, nothing. We just want to take already built executables and other files and take the files as they are unchanged and put them inside of the snap, which again is a compressed squashfs that's GPG signed. Okay, so the plugins currently available for the base Core 22. We've used Go previously, and now we're going to use dump. So ant is for Java things, this is for GNU Auto Tools, CMake, C#, Go language, Make, Java, Meson, build system, nothing, Node.js package management, manager, Python, Rust. Scons is similar to CMake. Flutter is a Google toolkit. So I'm not sure what kernel does. Conda or Colcon does, but we're left with just the possibility of using the dump plugin. So let's see what this thing does. So snapcraft dump plugin. This plugin dumps the content from a specified source. You can specify various details about a source using source keywords such as source and source type. Okay, so let's follow what's documented in here. So the plugin that we want to use is, so first of all, let's go at parts. This my part previously was the name of the application. So the name of the snap. Okay, so we do not need this line. This plugin is called dump. Okay. And we want to provide a source for the plugin. And the source is the directory, this guy. Okay. And then we want to put all of the files in a, not in the top level directory. So everything goes to bin inside of the snap file, of the snap file system. Okay, so the dump plugin is used mainly for two things. first to take already built artifacts, or as we did it with a archive or a tarball that contains built artifacts, and then copy it inside of the snap, copy the file as they are, maybe rename files or move files around. And the second thing that it knows how to do is this thing, which is called source type deb, where it takes an already existing deb file and takes its content and puts it inside of the snap file system. Okay, we're not using the source type deb, we're using the other functionality in the dump plugin, where it copies file from one directory to the snap file system. Okay, so this is what we have right now. Let's run it. Control S, just let's look again at the identifier. So my Geekbench, it looks okay. Let's see if it runs. Okay, so it took a bit more time than the previous snap to build it. Maybe it's the first time that we are building it, it takes more time. But also the files are really large. So we can see where it creates the snap file. That takes a while to actually copy 500 megabytes of files around and then compress them. Okay, let's install. Sudo snap install. And my Geekbench, like this. So sudo snap install auto-completes the list of possible applications from the snap store. So from the online snap store. And it downloads and installs any of these snaps if I want to. Okay. So again, it complains that there are no GPG signatures for this snap file, so we need to go -- dev mode, because we've started with the confinement dev mode. We're not at the confinement strict yet. Okay. So this has done the following things. First of all, it has copied the snap file to /var lib snapd and then snaps in here, and it has put an _x1 in the name of the file because we're sideloading this snap file. So we're not, if you're looking at the Firefox snap, it took the file from the App Store, downloaded it, and put it in here. Whereas where I'm sideloading, I'm not using the Snap App Store. I'm building snap files locally and installing them. It's going to use this suffix _x and then an auto increment integer number. Okay, and then this thing has also been mounted. into /snap /my geekbench / and then this x1 thing. Okay, let's look inside this directory. So there's just the meta directory that's created by snapcraft. That doesn't contain anything in the GUI directory. Contains snap yml, which contains some lines from that I have specified inside of the snapcraft.yaml file, such as this line. The first line is specified by me, specified by me, specified by me, specified by me. This architecture is added here by snapcraft while it built the snap file. This specified by me, me, and this again by the build tool by snapcraft. Ctrl-G, Ctrl-X-C. Okay, and then inside of the bin directory, the dump plugin has copied all of the files from the geekbench-linux directory in here. There's this extra file which I don't really need. The other files seem to be needed. Maybe this one not. Or maybe this is the entry point and then it will start the correct executable out of Geekbench AVX2 and Geekbench x86-64. So let's try to run this executable and see what happens. So cd listing, cd bin, and let's see if the files are executable. And they are, because I have downloaded the tarball archive with binaries, and inside of the tarball the files were already marked with an X chmod bit. So they're executable. /geekbench 6. Okay, and it does run correctly. And now it's testing my system. Ctrl-C to exit. We have a really great snap already. It works if you know how to install it. So if the end user knows how to handle this snap file, then our work would be done. But let's keep improving on the snap and remove the requirement that the user changes to this directory and then the user runs the file like this. Okay. How do we do that? Well, we'll want inside of the path environment variable of the current user to be an executable that's named my snapcraft. So very similar to what we had for my GoTop. Let's copy the entire part. So it says apps, the name of the app. The command is what we ran previously. So this thing. Ctrl-V. And we're not specifying any plugs yet because we're still at confinement dev mode. So we basically have no AppArmor confinement there. Okay, this should be it. Let's iterate one more time. So snapcraft. Let's also make a backup. My Geekbench. So we've added the snapcraft YML file. And we'll need to ignore this file. In here. So kate.git ignore, Ctrl V, Ctrl S, refresh, add the git ignore file, and that's it. Now we have two commits in the git history. First, we've added the binary files and a bash script that takes the original binary tarball, and then it creates a directory with an unversioned directory with the actual binary files. We need all of these files. If we would not need one, we could edit make.sh to remove some of the files. But these are data files. This is the entry point executable, and then this executable probably calls the correct one, depending on my CPU instruction set architecture and CPU features. Okay, the next commit, I say that the snap file that's generated in the top level directory of the Git repository should not be considered for version control. And I've added the snapcraft YML where I create the correct snap file and I expose bin geekbench 6 as the same name as that of the snap file. So that means that the executable my minus geekbench will be part of my environment variable path, so I can run it. Okay, so it built. We're installing it. We need to specify dev mode. And now we see if we have in the path my Geekbench. And it is in /snap/bin/my Geekbench. Again, /snap/bin is the last directory in my path environment variable. This thing /snap/bin. Okay, so we can run the benchmark just like this. And it works correctly, it starts working. Ctrl+C to stop the executable from running. Okay, so let's look at what snapcraft actually does when it builds this snap file. So it says launching instance, which is about LXD and virtual machine. Then it says pool my Geekbench. So my Geekbench is actually the only part. So this is the list of parts. There is just one part which is called my Geekbench, so the same name as the snap in this case. It runs pull, build, stage, prime. So the last step of the part my Geekbench is actually the prime step. So in here everything is built, copied. We have the opportunity at the prime step to remove not wanted files. And we do that exactly how it's documented in the plugin for the documentation of the plugin for dump. So the dump plugin. In here it says this part, so prime, like this. It says this minus, which is actually part of a list. So it says that prime is actually a list, and this is an item. This item is a string, and it starts with a minus and says minus means delete, and this is the glob. So all of the files readme.md, readme.txt, or readme without any extension. This is in this example. So for instance, we could break our snap file by removing one of the few files that are inside. Which is which? Where did we list the files that are inside? Yeah, this one. So let's delete this huge PLAR file and prove that the application stops working for this thing. As far as I know, I do not have AVX2. So Geekbench 6 will try to start Geekbench x86-64, will not find it and will fail and error out. This is because just before actually running one of the final steps, snapcraft, to create the snap, just before creating the squashfs file and compressing it and putting an GPG signature, it runs the part mygeekbench prime, which will delete all of the files that match this glob, which is just one file. And this also needs to be deleted from bin. Like this. Control S. Let's run the build again, which is called snapcraft. Starts the virtual machine. It says executed skip, so it does a build, not a rebuild of the snap file, which means it determines that this step does not need to be executed again. It was executed correctly previously. This was also executed previously correctly. This was also executed correctly. So not rebuild, but build. So it skipped pull mygeekbench, build mygeekbench, stage mygeekbench, could not skip prime mygeekbench. And it says reprime, so this is the running the prime step for the part mygeekbench, because the prime property changed. In here we've just added this property. And then it creates the snap file. Let's install it. Okay, let's run it. And it does run. That's interesting. Maybe I do have AVX2. What if I delete both? So geekbench underscore and then asterisk. Let's see if the file was actually deleted from here. So no, it was not. It was deleted. So for my Geekbench, there's two different snaps installed at the same time. There's the underscore x2 and the underscore x3. And there's a symlink which is named /snap/ the name of my snap, my -geekbench /current, which goes to the most recent version, which is X3. And in here, we only have the AVX2 version. So now we've removed also the AVX2 version using the glob. So asterisk means any character, any number of times, including 0 times. Okay, snapcraft. Okay, now we can install it. Let's see how many versions we have now. So we have just X3 and X4. So there's the current and the previous version from what I see. X2 has disappeared from here. And run the executable. And now the wrapper, which is called bin/geekbench6, try to find the best executable to run out of geekbench _avx2 and geekbench _x86 64, and could not find the version with avx2. It says unable to find benchmarks for the architecture of avx2, and it returns an exit status of error probably. Inside of bin, there's just a wrapper executable, and the other 2 executables are missing. Okay, so let's look at the lifecycle steps. So again, parts is a list. In my case, I have just one item. And for all of the items, there's lifecycle steps. So there's, as we saw in the output, pull, build, stage, prime. So pull, build, stage, prime. So it could point to, could download from a Git repository, to do a Git clone. A URL or path to a source tree to build. Okay, then the build part. Once the pull has finished, all of the components are there, but they might be in source code form. There's a Meson plugin, which Meson is a build framework similar to CMake. Executes Meson and Ninja to compile the source code. Built in different directories. One part can have a dependency on another part. There's the after keyword. So you can say part grv is after the part lib git2. So there's a directory named parts, and each part has a different directory. src build install. Pull build. What was that? Stage and prime. So there's extra steps, organize, and pack. Okay, stage copies the built artifacts into the staging area. So you have multiple parts, such as, I know, 2 C++ libraries and 1 C++ executable, so 3 parts. You build all of those, and then the build artifacts from the 3 parts get combined into a thing that's called the staging area. Make sure that you don't have 2 parts providing the same files with the same name. You can also do a bit of cleanup in the stage step, not only in the prime step. And then prime copies the files from the staging area to the priming area. Into the final locations in the snap file system. So in my case, inside of the bin directory. So it takes files from staging area and puts them inside of the priming area. Prime filter keyword, this thing. Okay, and you can run not the entire snapcraft.yaml file by just running the command line snapcraft, but you can say snapcraft and then the lifecycle part, lifecycle step. So you can just run prime if that's what you want. So running snapcraft prime also creates the VM, then pull build stage. Okay, and then there's also the command line shell, and it's shell after sibling. So shell says builds your snap to the lifecycle step, and opens the shell into the environment. So snapcraft and then the step. So if you say snapcraft prime, then it will run all of the steps until prime. And before actually starting prime, it will open a terminal shell connection console into the virtual machine as it looks there then at that moment. Or you might want to say snapcraft prime -- shell - after, which will run all of the steps until prime, including prime, and after prime is done, it will start a shell in there. And then snapcraft -- debug. At the first moment an error occurs, a connection to the virtual machine will be created and you will be inside of that virtual machine, such that you can inspect the error. Okay, so let's do this thing. So we get a shell after. Let's go with a shell after prime. We're in the correct tab. Nothing needs to be done. Everything has already been done. So everything will be skip. Okay. So skips the step pool, build, stage, and prime, because we specify we want a shell after, not a shell before the step prime. And then it says launching shell on build environment. And this prompt notifies me that I'm inside of the LXD virtual machine. These are all of the processes that are running inside of the virtual machine. There's a systemd that's running as speed1. There's journald, udev, file system in user space. So we have access to snapcore 20, snapcore 22, snapcraft. So snapcraft is actually a snap, and snapd. So snapd is both a snap and a Debian package. So there's snapd, snap package, and also the snapd deb package. Okay, what does this snapd do? I'm not sure. Let's inspect. So we want snapd and current. FC cache. A symlink to the parent directory. Install, configure, refresh, and remove snap packages. Snaps are universal packages. Start with snap list. AMD64 confinement strict. I'm not sure why this snap exists. It contains the snap executable, but they're not exposed. So you can access them like, where are you? Snapd dot something. Not really. Okay, so I'm not sure why that thing exists, but it's certainly available in the virtual machine. Okay, /usr/lib/snapd is running inside the virtual machine. It's running the prime step shell after, emd64, and it's running a Python script. Snapcraft provides a Python distribution. It's not clear for me where the source code comes from. It just copies the source code from the current directory to whatever, from the directory where we tell it. No, it's the entire current directory available there. And is this thing mounted or what? /root/project is probably bind mounted. Okay. So again, this is a virtual machine. This is running snapd. Has the snap executables from /usr/bin/snap. Installed from deb packages. Compression libraries, dash, bash, compilers, views, UpArmor, and curses for the terminal. Compression libraries, PCRE libraries, seccomp, Linux, make, GNU make, OpenSSL, the OpenSSH client, Perl. I do not see Python in here, but it's probably provided by the snapcraft. Snap list has these snaps available. These are the snap files that are inside of the virtual machine. Core 20, Core 22, snapcraft, snapd. We can install packages in here if you want. We're the super user. Snap installed from deb package. Git, GPG. Okay, so in case you have an error building the snap, you can decide where you want to connect to the virtual machine. You can connect just before the error happens by going snapcraft and then the lifecycle step, and either shell to open a shell before that lifecycle step, or shell after to open after. Or if you want to just open a terminal inside of the virtual machine exactly when the first error happens, then snapcraft space -- debug, and it will go straight there like this. Okay. There's a clean step Okay, so that's about it. Let's look at a KD snap and see what we can do with it. KD invent kcalc. This thing. Clone. Let's prepare a directory for it. Let's make the directory 3. Git clone. Okay. Let's see what's inside. There's a snap directory. Snap site directory with the a subdirectory local and then a patch. Okay. And in the top level, there's a snapcraft.yaml file. So this snapcraft file could be either top level in the Git repository named snapcraft.yaml. I have seen it also be in the top level, but a hidden file, so .snapcraft.yaml, and also in a subdirectory snap with the name snapcraft.yml, as we did until now. So let's read a bit of the configuration file, snapcraft.yml. We can look side by side with this and the first snapcraft that we did. Where are you? The go top one. Okay. So name, I'm not sure why it starts with a triple minus. Name, the name of the snap. Base core 22, so the newest, that's great. Confinement strict, that's loadable. Exposed applications, just one, the same name as the snap. So that means that the executable is not going to be prefixed with a snap file name, which is great. Now the applications that we've exposed until now are command line applications, whereas kcalc is a graphical user interface application. For that to work, it needs to be integrated inside of the start menu, similar to what happens with a Visual Studio Code. So it needs at least a desktop file, which the desktop file specifies the icon, the title, the subtitle, etc. So this thing /var/lib/snapd/desktop/applications. And the file name is code_code.desktop. The program to run is /snap/bin/code, so the name of the executable that's exposed in the path environment variable, and then puts additional arguments. Unity, I'm not in the desktop environment in Unity, force user env. Not sure what this thing does, maybe to inherit the user environment variables. And then the file name. Okay, then it says that it supports all types of plain text files, and also as parameter it can receive the name of the directory. So it can be dot, the current directory, can be other relative or absolute paths to directories. Name and description. It's for some reason executable. I'm not sure what this thing is. and the icon. So we'll need at least a desktop file for Kate also. And the name will be org.kd.kcalc.desktop. Similar, it wants to run the, so from inside of the kcalc snap, so inside the file system, there will be a directory named usr, a subdirectory bin, and this is the executable that actually needs to be run. Okay, because the application is confinement strict, it must specify plugs. So it requires desktop and desktop legacy, which are automatically connected. OpenGL is not automatically connected, not this. Audio playback is automatically connected, etc. So these are the minimum minimorum plugs that are needed for kcalc to run. I'm not sure why it requires network, because it's a desktop calculator, it's this application. Yeah, it needs networking because it has this functionality where it can launch web browsers. Possibly. But then why doesn't it require web browser? I'm not sure what this command chain is. I do not know what assumes is. It specifies a different compression. Let's see what the default compression is. By default, snaps are packaged, compressed, read-only, squashfs using XZ. And if you want improved startup times, we might want to use a non-default algorithm for compression. So snaps are compressed with XZ by default, and LZO is good at improving startup times, the call startup times for the first run. But the price is worth compression. So the compressed snap file that needs to be downloaded from the snap store will be larger in size with LZO non-default compression, but then the first start time of the cold start will be significantly faster in some cases. Two to three times improvement in application startup times for selected applications such as the Chromium web browser. Okay, so that's why kcalc selects a non-default compression, not XZ but LZO. Okay, I'm not sure what plugs is. We'll ignore this part, plugs, I'm not sure what it does. But this is probably about environment variables. Slots, so it says that it requires some interfaces, but then it also offers an interface, which is offered via dbus, and the name is org.kd kcalc desktop, probably for single instance. So if you have kcalc in here, then we select Firefox and then we try to open kcalc again. It just opens a second kcalc, so there's no single instance going on. I'm not sure then why do we need this slot. Okay, so it uses Debian packages, probably, from the Linux operating system that's named KD Neon User Edition. This is based on Ubuntu 22.04. And now we're at the parts part. So we usually had just one part, whereas this has more. There's KD Neon, there's patches, which we just saw the patch previously. In snap/local don't use full path symlink.patch. There's kcalc, and there's cleanup. Okay, cleanup runs after kcalc. Kcalc, where are you? Runs both after KD Neon and patches. Patches runs after KD Neon, so this is similar to GNU make file targets, which depend on each other. So there's a tree of dependencies. KD Neon will need to be built first, then this requires that, so the second should be patches, and then cleanup requires kcalc, so kcalc will be the next one, and then cleanup. So this is actually a ordered list. First part, second part, third part, and fourth part. Nothing can be run in parallel from the parts. Maybe different life cycle steps of a part of two different parts can be run in parallel. Okay. There's this thing which is called build packages and stage packages, which I do not know what it is. Let me see if we can expand this snapcraft.yaml file into a larger file that defines more completely what this file actually does. We can see prime, where it says minus, and then globs, which is similar to what we did, whereas this means remove all of the files /usr/lib, anything cmake. So it removes all of the files with the extension .cmake. It deletes all of the .h files. It deletes the man pages, the documentation, the spelling, dictionary files, etc. Okay, cleanup after kcalc. It uses a new plugin, which is nil. And then it overrides the prime step where it runs nothing. This is just a comment, and this tells the shell, probably bash or dash, to be verbose, to have debug output. We saw crafts, not craftctl. Okay, so this would be interesting both to run and see if it successfully builds a snap file, but also to run snapcraft and then a part or a lifecycle step inside of a part, and then tell it to open a shell before. So that would be snapcraft prime kd neon and then shell. Snapcraft prime patches and then ---- shell. So let's actually do that. So this is the directory. First of all, let's run snapcraft and see the output and give it ---- debug in case something goes wrong. We are taken inside of the virtual machine. I'm not sure if snapcraft reuses the same virtual machine for building different snap files. Package repositories. What's that? Let's look side by side with a snapcraft file. So it says executing parts lifecycle, but I'm not sure what that means. We're not into the individual parts, hopefully. It says installed package repositories, which is probably this thing. The virtual machine is Ubuntu 22.04 LTS, and I was able to install additional deb packages inside, such as Midnight Commander. So apt is configured correctly with correct Ubuntu 22.04 repositories, whereas this snapcraft says either we're not interested into using the Ubuntu 22.04 repositories at all, and instead use these deb repositories, apt repositories, or we need to augment whatever is in the Debian 22.04 deb repositories with this additional apt repository. It's also specifying the digital signature key that was used. Okay, I'm not sure why we're seeing this thing. It should say running part kd neon pool, and then build, and then stage, and then prime. Maybe so. Does it use a plugin? There's a plugin make which is GNU make. There's a plugin dump to just copy the file over. And a plugin cmake, because KDE Git repositories such as kcalc are built using the build framework cmake. And then plugin nil, because cleanup doesn't actually do anything. So we're now at pool KD neon, which is the first part. Then it goes pool patches. So the life cycle step pool, which fetches data from the part KD neon, could be run in parallel with the lifecycle step pool from the patches part, which is what it does in here. Then it went pool kcalc. So this thing, after it finished the pool for patches and for the parts patches and KD neon, probably it could do pool for the kcalc. Okay, then it goes to build KD neon. So it does some things in parallel as much as possible. It has a dependency resolve. It tries to see all of the parts and all of the steps, what's the dependencies between them, and run them as much as possible in parallel to use as many CPU threads as possible. Okay, then it goes, should not run pool for KD neon. I'm not sure why it tries to run pool KD neon twice and build KD neon twice. Okay, then it goes stage KD neon before actually building patches. Then it builds patches. So there's no need to prime the part KD neon. Once the files are in the staging area, they're available to other parts. So the files that KD neon part has put in the staging area are now also available to the part patches. So you can go build patches, which I'm not sure what it does. I just see copying. I'm not seeing the actual patch action. So this is where it says override pool. In here it goes call the patch executable. Okay. Then pull patches, build patches. So done that. The next step is to run kcalc. Okay, so it should have run kcalc pool first, but it probably has this override pool where it goes craft kcalc default and then patch, and maybe, I don't know, patching fails or something. Or no, pool finished correctly, but then the build for kcalc has failed. Which is which? The build part. So we're definitely inside of this part, because it says that failed part kcalc. And we didn't see verbosely what has happened in there. Did it run cmake? Did it install build dependencies? What did it do? But we're inside of the virtual machine. This part has failed, kcalc build. So we're at that step. Let's see if the packages have been installed. So the package minus list, grep this thing, has been installed. So I'm guessing all of these have been installed correctly. Let's look at the source files. So for that, who am I? I'm the user root. I can install packages apt install mc. Okay. Let's look inside of etc. Inside of apt sources list. So this is the Ubuntu 22.04 default /apt /etc/apt/sources.list. No debsrc. So has main restricted, universe, multiverse, and then also jammy up, and there's also updates, backports, and security. So this looks extremely default, and it uses http://archive.ubuntu.com, which is actually not a mirror but a CDN, content delivery network. So this provides the best speed possible. Okay, so this file looks okay. Inside of sources list D should be the one for KD Neon. So this thing where it says parse KD Neon, and then not package repositories apt main jammy, and this URL. So http archive neon kd org/user signed by this thing, this key ID. So this is the new file format for sources, where it also says the GPG file that's used to digitally sign this apt repository and the deb files inside. Okay, so basically it just overlays the additional deb packages that are provided by the KD Neon Linux operating system on top of Ubuntu 22.04, which is exactly what KD Neon does anyway, because KD Neon is an additional list of deb packages on top of Ubuntu 22.04. So those additional packages are for Qt 5, KD Frameworks version 5, any other KD Git repository built as a deb binary package. So this thing seems to have run correctly. This thing has run correctly. Let's see the last one. Installed. What about the ones in the stage? Done. This not. So at least it either we're before this step, and maybe just installing libmpfr also installs dev also installs libmpfr6. I would have liked to see way more verbose output, such that I know exactly what has been run until now. So let me see if I can increase the verbosity level of snapcraft. So let's exit, control, or not. Let's see what's inside project. Let's look at the readme file. So this is the kcalc kd git repository. Git remote -v has been downloaded using git. So it did git clone https://invent.git.org/utilities/kcalc.git. I'm not sure where it says that thing. This source, like this. So this part has been run, this part has not been run. CMake parameters prime certainly has not been run. I'm not sure if the patch has been applied either. We can check though. Where does it build? /usr, type release. Where is the build directory? -b -s. There's nothing, just environment variables. Whatever. Okay. Okay. Control D to exit the virtual machine. Snapcraft has finished, but with an error. I have a log. Let's see what's the problem. Failed to run the build script for part kcalc. Run the same command again with -debug, which we did. lxc -project snapcraft exec local cwd/root project env snapcraft manage mode pack brief. Okay, so all sorts of Python call stacks, because snapcraft actually contains a Python distribution and runs Python source code inside of the virtual machine, which is surprising. It should have run Go source code inside of the virtual machine. So this is the error that's shown in on the console. It has run the command /root/parts/kcalc/run/build.sh, and that has errored. So exit status non-zero. Okay, so there's a CMake error. Could not find a configuration file for ECM that is compatible with requested 5.240. 5.240 means KD Frameworks 6, whereas this thing is for KD Frameworks 5. So KD Framework 5 version is 5.100, whereas KD Frameworks version 6 is version 5. Almost the maximum, which is 250. So 240 means one of the last possible versions before the maximum version, which is 5.250. So that's probably because kcalc, there was some git branch changes, and now instead of building kcalc for KD Frameworks 5, the kcalc that's built is for KD Frameworks version 6, so not for Qt 5 but for Qt 6. And we'll fix this by specifying another git branch probably. Okay, so in case of an error, you have a full log, error log, and you have full access to the virtual machine at each and every step that you choose. Okay, so you can open a terminal inside of the virtual machine either before or after any combination of part plus step. So you can, the part would be KD neon, the step would be pull. So you can open a terminal inside of the virtual machine before or after pull KD neon, or before or after build KD neon, etc. Okay, and that's really it. Thank you very much.